Yeah, good morning, everybody. Thank you for the introduction, Bob, and thanks to Christy and Charlie for a good starting point. I think my presentation will be a good addition to your presentations. So let's have a look. So my name is Severin Todt. I'm talking here for the Lufthansa Technik. Lufthansa Technik is known as one of the world leading providers for MRO services, maintenance, repair, and overhaul services in the aviation industry. I didn't bring any slides talking about Lufthansa, but I would like to introduce a bit of it. Lufthansa Technik is organized in like 7 product divisions. We offer like line maintenance, base maintenance, engine services, component services, landing gear services, as well as some fancy stuff like VIP and executive jet solutions. So we're building the fancy cabins for the super rich. And right within the heart of the product divisions is where the central information management is located at. And within that IT department is where my team and I are responsible for the so-called CIX Competence Center, providing technologies in the CAD domain, including augmented reality, virtual reality, and digital mock-up technologies. As a second footprint, we just started to deal with the digitalization of our shop floors. So we have 2 teams in charge, one for the shop floors and one for the augmented reality stuff. And we just learned that it's a good fit. So we're using now augmented reality in the MRO processes, and that's what I want to talk about today. So the title is Augmented Reality and Application for MRO, and I would like to take you on a tour on our successful projects and to take a deep dive into the challenges that we are confronted with and the key success factors. So what I say is that the complexity of the MRO processes has been increasing in the past, and for my point of view, this is an ongoing trend, and the complexity will further increase in the future. The gain of complexity is, on the one hand, reasoned by the ongoing interconnection of our machines, equipments, and tools and systems, as well as, on the other hand, the automatic spread of information between these systems in a digital manner. So I say the paper as a valuable source of information will be vanished in the future shop floor. For the humans, it's getting harder to access these informations. So the humans are excluded from the digital information flow. It's getting harder to access process-related, context-related information, to feedback information. So what we need is, we need digital assistance systems. We need digital assistance systems to reduce complexity of our processes and to reintegrate our humans into the digital information flow. Upcoming technologies provide the power to unleash the information on our fingertips. By saying on our fingertips, I mean to provide the information in the right context, on user demand whenever he needs it, and in the right amount. So just providing all the information I have is too much for the shop floor. Process-related, context-related, and at the right place. Part of these technologies that are available are such as virtual reality, augmented reality, and we call it assisted reality. So to see what we understand when we're talking about virtual reality, we're talking about systems that are providing a fully digital representation of a virtual world. These systems are aiming at fully integrating the user into that virtual world by using immersive display technologies and immersive interaction technologies. Augmented reality, on the other hand, is a less immersive technology set of systems that is focused on providing visual information as a guidance with respect to a geometric constraint on a real object. So what you can see here is a screenshot from the HoloLens, and that's kind of fancy, but it's just showing what augmented reality is capable of. And then third, I was talking about assisted reality. And that's the one that I really like. Assisted reality, focusing on simplicity of usage, simplicity of technology, and providing the information in small bits, providing the information when the user needs it, so on demand, and using just the peripheral perception of the user. So not displaying in front, giving a clear side for his component, and just providing the information to the side if you're using a visual system, or even reducing the technology footprint more and using audio systems to guide a user. So how can these technologies be used to optimize our processes, to reintegrate the humans in the MRO processes? Virtual reality has been proven to be well suited for training and educational purposes. So it's a good choice to provide information in advance and apart from our shop floors as an educational measure to provide expert knowledge to reduce the subjective complexity of processes. So by providing information, it's easier to deal with the processes. In this case, we implemented a head-mounted display system. You can see a Gear VR solution. Of course, that is not a shop floor worker. That's one of the management crew. But we provided a solution for educating processes on our machines, on the shop floor processes, in order to prepare the worker for the next task. We have simple interaction devices, and it's kind of comfortable environment. But the idea behind is that we have information included in a head-mounted display that we can share all over the world. So it's not a stationary system, but we can share the knowledge. We can spread the knowledge. But how can virtual reality really help on the shop floor? Virtual reality is integrating the user in the digital world. But what we need on the shop floor is we need to interact with our colleagues. We need to interact with the component that we are working on. So virtual reality is not a good choice there. What we have there in place is augmented reality. Augmented reality is already in place in different use cases in the aviation industry as a visual guidance for navigation. And the idea of navigation was taken to the shop floor within another project. We implemented a navigation system for the inspection of airframe-related components. Airframe-related components such as the radome in front of the airplane or thrust reverser for the engines. We implemented an inspection guidance, tablet-based mobile system, guiding a user through the inspection process by providing inspection points as breakouts or highlights, geometrically overlaid inside of the user. So what you can see here is a real scene, the inspection points being displayed. The display system or the interaction system is displaying the inspection points as balloons, as an overlay. So for each inspection point, you have a geometric user interface. And these are color-coded, so the red ones are the ones you have to process, and the green ones are the ones that you already done. So by just interacting with the balloons, these are touch sensitive, you get further information on the inspection point. You get simple information of what to check and what to perform. This information is automatically fetched live from our ERP system. We're using SAP to provide the relevant information from the last version. For each inspection point, of course, you have to comment on the conditional state of that inspection point, so you can determine actions from a list of possible actions, or you can enter any free text, or you can even add a picture to that. That information is processed back to the ERP system in order to plan for further processes or work actions. The problem with that is, and we heard that before, it's a tablet-based solution, and applying this to a shop floor where I need both hands for the inspection process, that doesn't work well. So the worker would be in need of changing from the component to the tablet and back and forth again. So we didn't have a lot of acceptance there. For that reason, we implemented a glass-based prototype based on an Epson based on an Epson glass, which is providing the same information but has limited capabilities in interaction. Interaction is just performed by using some buttons at the glass. So we had, again, some problems here with the interaction. We had great interaction with the tablet, lower usage. We have great usability despite bad interaction possibilities. So if we can use a visual guidance system, we can also use an audio guidance system. For different shop floor, we'll just keep it really simple. We're just using an audio headset. So we have headphones, we have a microphone, and instead of being visually guided through the inspection process, we're taking an audio tool. Here you can see auxiliary power unit of an aircraft, and the guy is being guided through the inspection process. So it's an audio tool, and at certain inspection points, we are asked to comment on the condition and state. At this time, you're using pre-trained vocabulary to comment on the conditional state. So we have to train the system on that person, and the data being input is translated to textual information and then fed back to the ERP system. So that's a simple one. But how can these systems being used for real production purposes? How can they be used for the repair and modification processes? That was a question when we were asked by the VIP and Executive Jet Solutions if there's a possibility to assist in the installation of the perfect VIP cabin for the aircraft. How can augmented reality in any manner be being used for the installation process to benefit? What we know is that we're using digital mock-ups, 3D models of our cabins for years for evaluating the 3D engineering model. We're using a CAVE system, a multi-display system, to evaluate the system to see if there are any interferences, if all the interconnections are met, and if there are other design problems. So we're using the CAVE already to establish the perfect 3D engineering model ready for production, before even production starts. And we do also take the shop floor workers into our CAVE environment to double check the 3D engineering model from a different side, from the production side. So we're using the CAVE environment to develop the perfect installation strategy to take a look at the 3D engineering model, if that model is producible and installable in the cabin. So the engineering part is not really understanding, the production part. So we're using this technology. So the idea was just bring that 3D data into the aircraft in order to support the installation process. And we took this almost the same ideas in the CAVE, a projection-based system, into that aircraft. Oh, sorry, that was the right one. We took the projector into the aircraft and just projected the 3D engineering model into the empty airplane. This is a prototype we've done like 2 or 3 years ago, starting with an office projection system. There was a student, did that in a week or so. So we had a system ready to prove the concept and realized, oh, that could be a big help there. Nowadays, we developed that product. Nowadays, we're using a high-precision laser projection system to project mounting stencils based on 3D model into the work area. So we're just pre-selecting relevant 3D contours of a 3D model, as you can see on the left hand. And these contours are projected in the work area for the final installation. The laser projector itself is referencing itself automatically in the aircraft coordinate system by using a marker-based system. On the top right, you can see one of the circle markers. So the laser projector can be moved within the aircraft, so for different installation procedures to be used. The final installation procedure is then as simple as just aligning the real edges of a component with the projected contours. So by aligning the contours and fitting the contours, you find the final installation position to mount that component. Using that system, we could reduce the installation hours about 50%, so that's quite a good success. Besides the success, it took us like 3 years to implement that system. I don't know what was harder to present or to get the allowance from the management to go after that, based on the prototype from a student, or convincing the shop floor workers to use new technology. I think at the end, the management was the major constraint. So they had to spend the money. The shop floor workers loved the system, or still loving the system, especially because they feel a real relief in the installation procedures. Like we have in the non-constant area of the aircraft, we're using a lot of mechanical equipment and measuring systems to find a final mounting position, like in free air. It's pretty hard to determine the position. So what we learned with that project and the tablet-based and glass-based solution is that there are some key challenges that we have to deal with in order to implement successful applications to bring augmented reality to our shop floors. From my point of view, there are 3 major challenges. We have to keep it simple. We have to keep IT simple. We have to learn what the needs on the shop floors are. We from the IT department, we have to spend a lot of time on the shop floors to understand what the needs are, what the problems are, and how these guys are used to solve their problems. That's not actually what we think, how they solve the problems. So listening to the people. We have to learn to think shop floor. We have to learn to speak shop floor in order to provide new assistance there. The backend integration, the backend systems that we have in the IT departments are the informational heart of our shop floors. Without the information from our backend systems, we're unable to provide anything. Could be the PLM system, the ERP system, the manufacturing execution system, all these systems providing and receiving the information to and from the shop floors. So integrating these systems into our applications as one of the key factors. And last but not least, it's the user acceptance of the systems. We have to take care of the users. We have to listen to the users. We have to create application that they can use. And we don't have to introduce too much technology at once. So it's not a good idea to encounter process complexity by introducing technological complexity. Again, we have to keep it simple, and we have to take a look critically at new technologies. We have to evaluate technologies if that is rocket science. If that's real rocket science, probably it's not suitable for the shop floors. So maybe some slower involvement, but focus on the user. Lucky me, we just opened up a joint center of research for applied research in the aviation industry in Hamburg, which brings together researchers and shop floor innovations in one center for the aviation industry, primarily of German companies. So we have a joint research with Airbus for example, and the provider suppliers such as steel, cabin or something. So we can enforce, or we can join our efforts to build up new assistance systems, because the problems, as we've seen with Lockheed Martin, are the same. So we can build the future of our shop floors, of our production together, and to provide new assistance systems. And that concludes my talk. I'd like to thank you for your attention.